So, Adam, if you remember your riser, we brought that from the transformer, guys, we brought to the CT cabinet all the way to the auto transfer switch. Then we have a big fat generator sitting right here. Now, when you guys did the feeder schedule, you guys remember that? I told you to hold on the generator until we size this generator. We can't predict what size it would be, but we're going to hold on that one. So today we're going to size the size of the generator in kW. What size kW do I need this generator to be? Cool. So in order to do this, guys, we have to have a few things. I want to remind you guys the way they size generators. We'll get back into this one. So that's what we're trying to do. Everybody's cool with that? So that's my generator. In order to follow with Chad, please do me a favor. Go open your load calculation Excel sheet. So have Excel sheet load calculation that you guys done with Chad open. Have a project narrative open and at 0.5. What would that be here? Right here at 2.5. You need these open. One more time. Have the project narrative open and go to 2.5 mechanical equipment, and also have your load calculation open. Give me a thumbs up, please, when you're done. So, Adam, you're good? Okay. Matt, working on it? Okay. Good. Derek? Oh, loading it? Okay. Karen? Loading it? Okay. You need these two documents in order to do load calculation. These two documents. You can have them open, guys, electronically, or you can have them in front of you. Okay. This is what we're going to be doing, guys. And then the third thing I would like you to do remember we downloaded the software, this software from Cummins? Everybody can see the icon? You guys, your icon should be on the desktop. Go please fire the generator. Double click on the software generator, and let's go ahead and size that boy. Open Cummins generator sizing software. Okay, when you open it, it will tell you guys you need to register. You can register at any time, but okay. When you're here at this point, double click on the project. If you double click on the project, guys, it gets you into new. If you have an existing project you want to open, it will refer you to an existing project. Otherwise, double click on the new file and new project, or it will get you here and double click on this one. Now you got yourself a new project. Can you guys see that? Everybody have a new project right here? Yes, good. Okay. Expand that new project. Could you please expand that new project? Now you have a new project. All the manufacturers, major manufacturers of generators, Caterpillar, Cummins, Kohler, all the manufacturers, guys, have a little software like this that they give to the engineers and designers like yourself. It will help them size the generator. I don't know if you guys recall last module, residential project, when we talked about sizing a generator. You size generator current based on two things. Number one, the running load, how many kW you want to run at the same time, simultaneously. That's called the running load. And how many kW, that's number one. How many kW you need to start from zero at the same point, at the same time. Did you guys hear me? So when you size generator, there are two factors on how big, how fat, how expensive the generator would be. First is what type of kW you need to throw in this generator and run simultaneously. And how do you want to start them? When you lose power, do you want to start everything at the same time? That's called all of them on step one. The steps will decide how are you going to start them. If you're going to start them all at the same time, put them on one step. Flip the switch or the auto transfer switch, guys, since that you lost power. A storm came, hit the transmission line, lost power. Auto transfer switch, since the absence of voltage is absent because they have DC sensors on them. Send the signal to the generator. Go ahead and fire. Generator fire. Come up to speed. 60 hertz. Everything is loaded now. Now, how do you want to? Then the auto transfer switch, when it sees the voltage here, it's going to go slam and turn the whole building into the generator. Okay. Now, after you turn the whole building on the generator, you can control which load comes first. Which load are you going to be bringing first? First meaning 10 seconds. Every 10 seconds or so, you can bring chunk of loads. If you do it this way, guys, it will help the generator start. It will make a smooth run and start with the generator. If you ask the generator to start everything at the same time, your generator, instead of being that size, Karen, will be that size. Because you have to have a capability, a huge amount of starting capability. Starting load versus running load. So your job is to minimize, try to start them in gradually, in steps. What's the most important thing? Starting. 10 seconds, start the second thing. 10 seconds, start the third one. And the fourth, and the fifth. How do you control the start though? For a project like this, we have one auto transfer switch, guys, so we're going to throw them all on. We can control them either by controlling the circuit breakers, so you have to have a special circuit breaker to control, or you can control them by controlling the contactor. For example, we lost power, right? When you lose power, now your air handling unit is down, Derek. When you lose power, your air handling unit is down. So what you can do, you can put a delay, a relay there that delay the start. Now your generator starts. When it starts, part of the control system, you can make it a little relay or timer, since now we have the generator is up. Now please hold for, depending on how many what step is the air handling unit. You can make the timer, just a little timer, say time it and say don't start the air handling unit until the generator has been running for a minute. Do you see what I mean? That's how they control it. Little timer can make the air handling unit start at a minute after the gen comes. So that's that's if you have one auto transfer switch. If you have multiple auto transfer switches, you can have transfer switch 1 close first, wait for 10-15 seconds. The auto transfer second auto transfer switch closes, and the third and the fourth. That's if you have multiple auto transfer switches. We only have one. When we do the industrial project, Karen, we can control the circuit breakers. So what they do, they have big circuit breakers like these guys. They send the signal to the circuit breaker. It says start now. And the one right underneath that, these are bigger circuit breakers. They say wait for 10 seconds. They put these timers part of the control. So everybody understand how you control the start of these projects, of these loads, by either manipulating their control, put the timer, and just delay them. And we're talking about seconds, guys. We're not talking about hours. Okay. The first thing when you get into this project is you need to go put the project parameters. Can you guys see where the project is? Edit. And here's my project. Edit. I need to go set the project diameter. Default size. Let's go set on my default size. Okay, this is what's your default size. Everybody's there? Did you guys get that screen? Okay. So Karen, we have number of generators we're running in parallel is 1. How do I know it's 1? You start with 1. If you can't pick up the load, you put 2. If you can't pick up the load, you put 3. Meaning it will give you an answer that says, hey, too much load, I don't have a generator that can pick it up. So you go back here and put 2. Hey, too much load, I can't pick him up with 2. You put 3. That's parallel generator. So we're going to start with 1. There's something called, guys, minimum generator set load allowed, percentage of rated capacity, 30%. These are leave them as default. Voltage dip at start, you are allowing the voltage to dip, means low, go down on the generator up to 35%. Leave this. These are standard by the manufacturer. Voltage, allowable peak voltage dip. All these guys are leave as default. Did you guys hear me? Allowable frequency dip, 10% frequency will be screwed up when you start. Okay, so that's okay, that's fine. Then altitude. Altitude, that's where you set, guys. Where is the generator going to be installed? What's the height in Minnesota? In Minneapolis here? 800? I think 800, something like this. I thought it always here. So you're going to find the height of the area that you're in. Let's just assume it's 800, guys. And I'm going to go put 800. 841? Wow, there you go. 841. 84, I thought we researched it. We are at 841. Because that generator is going to be in Minnesota, in Minneapolis area, you know, because it differs even. So 841. Why do we care about the elevation, guys? Because the more, if you put it in the Himalayas, the pressure is is low on these generators, and they will be working harder. So you have to derate them. The higher the elevation of the generator is, the manufacturer, the more you have to take this into consideration because the generator will be stressed. Did you guys hear me? The generator will be stressed. Okay. Now ambient temperature, degree Fahrenheit. You can change this one. Ambient temperature. They're outside, so we'll have an ambient temperature of an outside of it said 77 here. They're sitting at ambient temperature of 77, but you can run it. So let's say 80, 85 Minneapolis ambient temperature. Okay, then sound attenuation, quiet site. Are you going to be putting it in residential where Chad's wife will be yelling at you every time you crank it? Or is it industrial they don't care, right? So let's say this is the location where you guys go to Hallberg. This is a residential area, mixed residential commercial. So we need it to be attenuated. So you hit your attenuation quiet. So when it's quiet, what they do, guys, is they have an enclosure around it. They attenuate, they basically neutralize the noise by killing it inside the enclosure, which means the enclosure is going to be bigger than what's not. Okay, here's my quiet side. And allowable alternator temperature rise, don't mess with that. That's for the manufacturer. Calculate voltage and frequency depth, leave that alone. Okay, now, Adam, what type of fuel do you want? Your default is diesel. Either you can propane or natural gas. So typically they default to diesel, okay? Then frequency, can you guess three-phase? Is it a single phase or three-phase? It's a three-phase. And then right now is the voltage. Look at, we're sitting right now 277, 480. Is that the voltage that we need to size for, guys? It's a 28120. 28120. So here's my where's my 28120? Can you guys see that one here? 122.8. Everybody, can you guys change it into 122.8? Everybody found the 122.8 way at the bottom? So it's a Y generator and it's 122.8. Cool? Everybody got that one? Huh? It's a Y. It should be a Y all the way down. It's a Y. So we want a 122.8 parallel Y generator, typical. Okay? Frequency. Are you in Europe or are you going to be using 60, 50, or are you here in the US going to be using 60, of course, in the US? Duty. Duty, when you click on the duty, guys, do you want this generator to continuous means 24/7? This gen will run 24/7. Does EPA allow you to run a generator 24/7? And Brian, working at Excel Energy, will sue you because they want to sell you power, right? In the US, I don't think of any place where you can run 24/7 because of EPA requirement.
It's a standalone system.
Yeah, even a standalone system, EPA requirement will make it so hard for you to run 24/7. You got to be in a place where there's nobody lives or what's not for commercial. If you're living in the boonies and you have your own generator for your own house, we have freedom and liberty here, right? You can do anything you want to do on your farm. But if you're like Dunwoody decided all of a sudden we're going to get off the grid and put 6 generators here and run, EPA requirement, guys, will make it so hard, so expensive for them to do that. So hard, so expensive. So long story short, ignore that one. That's continuous. Prime duty. I think if you want to run them non-continuous, not continuous, but you run them a lot more often for backup. Prime duty, like a backup. For backup, you're not just for emergency, for backup. Prime duty, so you can run them. So yeah, so you run them more often, but not 24/7. Almost all the generators that we size for buildings, guys, it's called standby duty. Did you guys hear me? Standby. Meaning if you lose the power, you can fire these babies. That's all. You lose the power, you fire them. That's the only time you run them. And they exercise them monthly for half an hour or not. Just exercise them, unloaded and exercise. And you lose the power, you fire it. If the power is there, you shall not run it. Cool? All right, so we're done with that one. That's your parameter of your project. So we're gonna go. Everybody got that one, guys? Hit OK. So we're done on that. If you click, do me a favor. Now click. Make sure you click on New Project. Can you guys click on New Project? It's blue. Go back to Project, And let's see, select, now we selected the generator default. We're going to select the project parameters. Right underneath it, you see selected project parameters. Did you guys see what I did? In order to get that one, this have to be blue. New project have to be blue. Then go project again. Now we're going to go select the project that we're going to work parameters. Okay? This project is called commercial project. Oops. Commercial project. And comments, I don't know, whatever comments. So here, what I would like you guys to fill this information here, and you can just put right now info, line 1, headers in the report. This will all show in your report. So you can fill this information. Who this project comments, this is for Minneapolis or what's not. And you can fill all these. That's going to show in your report. So I would like you guys to fill it with certain information about the project headers, like this project is for the owner, the name of the owner is this, the address, and what's not. They use this information when you generate a report. Eventually, when you generate a report, that will be at the top of your report. So what do you want this report to show? Minimum, your name, your company's name, who the customers are, right? That's minimum. So you need these lines to show who are you as a company. You know, you're doing it for Mishad Kuli Erickson, so you put Mishad Kuli Erickson and their address, and who the generator is for City of Minneapolis. Okay, so you can fill these. You don't have to fill it now, but just put something there so you can get back, guys, and just put a couple of things there so you can show in the report, like a couple of letters, will you? Okay, parameters. Then you go back to the parameters. Oops, I think we did the default. We shouldn't have done that. We did the default. So general, the parameters, can you guys go do the same thing here? The only thing we need to do change here, remember the 800, actually we did the default here. We shouldn't have done the default. Change this one to 800, 85 degree, a quiet site for this project. The same thing, I'm going to do it, standby, and change the voltage, my friends, into Y to 8120. Okay, do you see what I changed the voltage? Y to 8120. Standby, quiet, 800, 800, what did you say, Derek? It was 841? 41, thank you, 841, and temperature is 85, and in a quiet site. Okay, this is the one that we were actually changing was the default. So if you, the one that we changed now, it's going to default it for every project that you do is the way it should have been on the project. That's just for that particular project, so not a big deal. So you see the difference between this one and the other one. So here's the information about the project. Here's the parameter that you need to change. Okay, when you're done, are you guys done with this? All the way down. Scroll all the way down. You just need coffee. Okay, hit OK, gentlemen. Your generator is ready to be fired. Now, this is the type of the gen that I need. Now, the next step, any question, guys, about setting up the information about your project and your generator? Always come to the commercial. Here's my, it looks like commercial project here, shows it. If you want to change any of these, you can go back here, guys, edit, and you can go, okay, always go, don't go to the default like I did. Go to the selected project parameters, and you can change them here at any time. Done. Step 2. Step 2 is we're going to put the loads now. We're going to put the loads. So let's go click on load. Okay, click on the word load. So you need to insert your loads in it. I want to remind you guys, I have a lighting panel and a receptacle panel and a multiple other things in between. So what I would like to start, so let's start first with the lighting panel. Let's go put the lighting panel, load. So in order to get the load for the lighting panel, here's what you need to do. Minimize this one. Go to your load calculation that you guys did with your friend Chad. If you don't have that number, you're going to get a number. Oops, where did it go, Chad? Here. Okay, so I want to remind you guys, here's my load calc. Here's my lighting panel. Do you guys remember that lighting panel that we did? Here's my lighting right here. I want to go back down all the way to the KW of my lighting. KW all the way when you did the lighting. Oh, come on. Okay, So this is, I believe, is the load that we did for my lighting. Okay, now, no, this is a neutral, Chad. We need the phase. So if you click, guys, here all the way down, it should get you total volt amp. Is it? Yeah. You need to total demand load in volt amps, though. Step number 5. Step number 5. So that you're looking at this number, which is 68719. Everybody got that one? Your number probably close to this. Adam, did you get your number close to this? Something like this? Now, for your lights, guys, your light, the stock is not a whole lot on lights. They are not motors. So we're going to go lump sum them, grab all the loads, lump sum them as a KVA. Lump sum them as a KVA. Okay, I want somebody to remind me of that number here when we get to it. What did it say? 68719. Okay. Can anybody remember that one? Well, let's write it down because I'm going to go 68719. Okay. So I'm going to go now. I got my lighting load. I'm going to go back to my generator load. Okay. Now here's the option that you have, guys. If you just hover over the first bulb, what do you think the bulb looks like? It's new lighting load. Right next to it, if you hover over it, it says new air conditioning, chillers. Right next to it, new battery charger. Right next to it, new medical imaging load. Right next to it, new motor. So if you need a motor, you put the motor here. Right next to it, new fire pump. Right next to it, UPS. Right, you can put your UPS here. Right next to it, miscellaneous like receptacles and what's not. Okay, so these are the type of the loads they're going to be using. Everybody's okay with this? Karen, everyone is okay with the type of the loads that we're going to be using? Yes, no? Type of the load. Okay, let's start with the lighting load. Click on lighting load. When you click there, the name of the load, please type LP. That's my lighting load, LP. Adam, you have the option. You type LP, you have an LP. You either put them as KW or KVA or amps. Now remember, our calculator gave them in KVA. Everything is KVA. So click on KVA, and I'm going to go put this number that we just got. 68719.
That'd be 68 point somewhere.
Thank you.
Ooh.
It's in KVA. Oh, here you go. There you go. Thank you. Now, I mistake number 1. Because it's given in KVA, you're right. It's 68.7. 719. I don't know if I allow you to go to 9.72, basically. 68.72. 72. Extra credit for Derek. How you'll get 100 points. You have to ask me. You have to ask me out of what though? 100 points out of what? 100 points out of million is nothing, right? You would have realized that, guys, because you're gonna get up. It will tell you there's no big generator that can handle it. So you say, "Wow, that's a small load." So you would have realized that if you did that mistake. Common mistake. Okay, so here's my KVA. Look at this. What's the voltage? It's 208. It's 3-phase. Now I know the lights are single phase, but the panel that feeds the light is a 3-phase. So it will be all seen, Adam, as big chunk of 3-phase load lighting. Cool? Right underneath it, what type of light are we using? We're using incandescent discharge fluorescent. Now, I will take you back, guys. Generally, look at all the loads that we did. Don't you agree with me that almost 90% of what you used was fluorescent lights? In one way or another? There was a couple of incandescent here and there, okay, and a couple of high intensity discharge outside. So I'm going to lump sum them with this category. It wouldn't make a whole lot of difference. Did you guys, why I went fluorescent? Because almost, if you want to be picky, like Adam probably, you can split them into different types of loads and lights. But for this application, almost all of them, 85 to 90% are fluorescent. Lump sum them as fluorescent. But you can change it here. Okay, that's all. Then I want to bring to your attention, guys, it says running KW. It gives you now the running KW and the starting KW. Running start. Can you guys see that at the bottom? You can put any comments here for yourself under this load. You can write a comment or what's not. Don't usually require you. So if you're going to say, 80%, let's just say this one, 90% is fluorescent. And it's built fluorescent right there. Fluorescent, something like this. So it'll give you an idea that there are 10% who are not. Okay, can write yourself a note here. And I want to bring to your attention, guys, the running kW, the running kVA, the power factor is 95%, the running amp is 190, the alternator kW is 65, the starting kW, the starting kVA, and the starting power factor. All these are calculated through the software. Go to next, will you? Next, it will tell you what's the power factor of these lights. You guys, okay, the default is 95, running and starting, and that's good default. We'll leave it for lights. Assume we have a 95. They have typically in the 90s, not bad about fluorescent lights. So electronic ballast, 95 power factor. If you know it's different, what do, Adam? You can go change them. So we take the default, and when you're done, gentlemen, what do you hit? Finish. Gentlemen, welcome to the first light that we dropped you lighting panel load. Any comments, Karen? Did it work for you? Are you okay? Did it work for you? No, not yet. So that's your lighting panel. That's your lighting panel. Any comments, guys? Any questions about your lighting panel before we go to the receptacle panel? That's it. That's all your lights, lump sum, Adam. How hard that is. If you have 2, 3 other lighting panel, what do? Do the same thing, lighting panel. 1, 2, 3, 4, 5, 6, and add them all. Okay. Shall we go to the receptacle panel? Receptacle panel. Receptacle panel. Okay. The receptacle panel. Receptacle panel, guys, let's go find the actual load of that receptacle panel first. So let's go add them to our... 32,398. I don't trust you, my friend. So I want to go see how much I came up with. So each one has its own, guys. You're going to be using your own number that you came up with. Right, wrong, or ugly. Let me see what I came up with. 32.398. Is that what you said? I told you, Doubting Thomas. So it's going to be in kW. It's going to be 32 point... where am I here, Chad? 32.4. Shall we? Right? It's 32.4. Can somebody remind me of that? 32.4. Okay, so go do me a favor. Go click. Where would you put the receptacle load type, Anna? Look at this. If you hover over this, it will give you miscellaneous. Can you guys see that? Click on this. Miscellaneous. It says, what do you want? Welder, user-defined, or general receptacles. Click on general receptacles and double-click on it. Double-click on general receptacles. One more time. Let's go back. That little guy here looks like it says new miscellaneous load. Double-click on it, and it gives you welding or user-defined or general receptacles. What do you think we're going to do? General receptacle. Double-click on that. Double-click on general receptacles. Okay? Then right here, guys, put RP, my receptacle panel. Receptacle panel is coming in kVA. It's coming in a kW. Well, let's assume our kW and kVA are the same. The power factor of 95 is not going to make a whole difference. So what was it? It was 32? 32.4. 32.4. 32.4. And can you guys see what my kVA now is? 36. My kVA is 36 slightly because I'm putting it as kW. I'm putting it as a kW. So if you want to manipulate it, if you put 30 here and you look at the kVA, here's 32. Can you guys see it? If you put 30 kW, it'll give you a running kVA of 33. And we're looking for what? 32.4. That's very close. Do you see what I manipulated slightly to get me close to the kVA? One more time. It was 32.4. If I put 32.4, it was a kVA, not kW though. So manipulate it slightly and look at the kVA here, give you 33.33. That's good enough. Comments? Let's say receptacle. Receptacles. If I spelled it right. Cool. Let's go to next. What's the power factor assumed for the receptacle, guys? Assume 90%. You're assuming 90% for receptacles. That's what the default. Unless you know otherwise, what do? Don't mess with it. So leave it at 90%. Why? If you go below 90%, you're going to be penalized by the grid. So typically that's assumption. And gentlemen, when you're done, you hit finish. I have my receptacle panel already modeled. Any comments, guys? Any questions? Any comments? Any questions?
What was the power factor on that?
It was, I left it as 90. I didn't change it. Okay. Now, these are receptacle panels and lighting panels. We lump sum them as a load. The mechanical equipment, gentlemen, ladies and gentlemen, the mechanical equipment, because they have a higher starting capability, we don't lump sum them. Did you guys hear me? The bigger motors, we put them as a standalone. Did you hear me? If they're bigger machines, we put them as a standalone. Okay, so what I would like you guys, the next step is kind of the little bit of tedious step, is we're going to go input all these equipments. Let's go directly and see which equipment we're going to start with. I'm going to do one or two of them, and you guys will do the rest. There you go. So let's go back into, here's my mechanical equipment, Adam. All these, can you guys see from 2.4, mechanical 2.5, 1 all the way to 15. Did you guys that? 1 through 15. 2.5, 1 through 15, you need to go input them in the software. Now, Derek, here's how we're going to do it. Number one, I would like you guys to follow the following. Look at the horsepower, look at the voltage, look at the three-phase, and look at the starting capability, it says VFD, and look at the unit. These are the information that you're going to be picking out of this sheet. Okay? It's an air handling unit. It's a 15 horsepower, it's 208, it's three-phase, and how are we starting it, gentlemen? It's VFD, okay? Let's go to the one underneath it. This is a condensing unit. The amps, here's my amps, and it's a three-phase, and it's a 208, and provide fuse disconnect. Did they say anything, guys, about the controller for this condensing unit? Nothing. So that's provided by the manufacturer. Now, typically, the condensing unit, Adam, they're always, all the chillers in the condensing unit, they have VFDs on them. So when we model it, we're going to put the VFD just for the system, VFD. Okay? Let's go do these two, shall we? And then you guys will do the rest. So, can somebody remind me, the chiller is 15 horsepower. Let's do the chiller. Okay, now, motors. Here's where you're going to be modeling, because this is his motor, right? You're going to click on that. Now this one, this is fire pump. That's your pumps. Click on this. The first one is going to be air handling unit. Air handling unit, AHU, air handling unit. If there's 5 of them, you put 1. Is it given in horsepower or kW or amps? Can you guys see that you can have the option of flipping between amps or horsepower? It's given in horsepower. Was it 15? Right, Derek? It was 15. The voltage was 208 three-phase, isn't it the default? Yep, that's a voltage 208 three-phase. Any question, guys? So here's my air handling unit. Next. Now, motor type. Are you putting a variable frequency drive on this baby, or are you standard NEMA? Unless they tell you a VFD, what do? Standard NEMA. Except for the chillers, the two chillers, guys, almost always the manufacturer will have a UFD on them, VFD. So your two chillers, or condensing unit, your two condensing unit, please put VFDs next to them for the sake of the software. Okay, now do we have a VFD on this one? Yes. Click on VFD, Adam. What option? Conventional inverter or pulse width modulation? Can you guys see typically pulse width modulation comment? So click on pulse width modulation. So what I did, I clicked on the type of the start is going to be a pulse width modulation variable frequency drive. Why? Because when you start at when you put a VFD, guys, the VFD will reduce the starting current and torque, the starting current typically and the torque even on the motors, and by reducing the starting current, it will reduce the starting capability of a motor. So the motor doesn't have to start a huge load. It just gently, slowly, the VFD will ramp up this motor. You see how it's important to put the starting capability? Okay, comments. Let's say VFD here on it. VFD, just has a VFD on it. Let's go to next. The power factor is given as 90. You can't change it. The running power factor, it's set at 90%. Efficiency at 90, unless you know otherwise, Adam. What do you do? We don't know. So that's enough. Good enough. Default. The worst. These are guys, typical industry standards. They are in the system. Unless you know, what do you do? Leave them alone. And gentlemen, ladies and gentlemen, hit your finish. Here's your air handling unit. Matt, does it make sense? Shall we go to the chiller 2 or condenser unit 1? The first one? Okay, condenser unit. So let's go to condenser unit. Now, Adam, condenser unit 1, CU1, it's a 208, and the amps, can you guys remind me of the amps when I go there? It's 81.6, okay? 81.6. Remind me, will you? Okay, what type of load is a condenser? Can you guys see that little, what do you call this? It looks like, okay. So click on that one. That's your chiller load. Oops. Okay, moving to the chiller load. Everybody got the generator? That's mechanical chiller load. Put this one CU-1 because you have two of them. Okay, now they're given in tons. They're given in tons. So in order, guys, for us to size them, you have to find the tons for them. How are you going to calculate that one? I would like you to look at okay, so what was the amp that we were looking for? I want you to look at this one right here. We were looking at 81.6 amps. Okay, so what I'm going to do, I'm going to go start with a number there and keep watching. So let's start with 20. Okay, what's my running load? 108. So it's less than 20, isn't it? You guys, I just put 20. Okay, so not far away. So let's say 17, 88, and I'm looking for 81. All right, so 15, 79, not more than say 15. 15.6, there you go, 15.6. 15.6 kW give me an 81.6. Thank you, right on the money. Did you guys see how I kind of trick it to find what from the tons, which is mechanical quantities. In real life, Karen, the ton will be on the mechanical equipment, and you will get it from mechanical engineers. You know, did you guys hear me? You will get that information from mechanical. If you did not, that's how you trick the system to get you how many tons. So this is 15.6. You know, with tons, I don't like to go 15.6. Let's go 16, guys. Just 16, a little bit more, give you 82. So go 16, so a whole number, 16. Okay, next, let's say what type of a start on it. We didn't say anything about the start. Knowing how they run these, Adam, they always run them with VFDs. So let's go VFD again, click on VFD and pick what? Pulse width modulation. And I'm going to say VFD by mechanical contractor. So mechanical contractor will provide the VFD. So I know I'm not providing it, or the manufacturer will provide it. Cool? Everybody's good with that? Then you go to next, and next, gentlemen, it gives you, if you want to manipulate the frequency of the power factor, unless you know, what do? Leave it alone. And off it goes and finish. Off it goes and finish. Okay. Let's go take one more load, and then the rest you guys will start doing it by yourself. I'm going to take one more load. I'm going to go add them to this. The future condensing unit, you guys will do it the same way. But please be aware, be with me for 1 second, will ya? I'm going to go use number 5. Boiler pump 1. Boiler pump 1, it's 2 horsepower, 208, 3 phase. disconnect, provided starter disconnect. That's what they provided. Cool? Everybody see that? Let's go model that one. It's a 2 horsepower and it's starter combination. Okay, so let's go. It's a motor, so you go to the motor. It's boiler pump dash 1. The horsepower was 2. The voltage 28120. Now, the starter was a combination. A combination is not VFD. So you're going to stick with the standard NEMA. It's a NEMA standard. So leave it alone. Is it NEMA high efficiency a motor? We don't know. So leave it alone. And then say it's NEMA. NEMA starter. Um, and okay. Is starter E or O? E. Okay, I always get confused. Good. Okay, that's it. Then you go to next. It tells you, are you going to start it across? Look at the starting capability when you go next, guys. Are you just putting across the line? Are you have Y delta, part winding, resistor, reactor, auto transformer, solid state? Now, Adam, when you have motors, you guys, I know you did it. I know Karen, you did it. Who else? When you guys were in the motor lab, do you remember that Y delta? When you wire a motor Y, reduce the inrush, and then you flip it into delta to reduce the starting current. Or you can have part windings. You put part windings, you energize the first set, then the second set, so reduce the starting. All these are ways of reducing the starting current. Solid state, they call them soft start, Derek. Does this motor have a soft start on it? No. So if it doesn't have any of the following, it will be written, by the way, if it says so. Then what's your default? Across the line. Across the line, this is mean NEMA. Dumber than a rock. You close and open. That's all what it does. Doesn't reduce voltage in any way, shape, or form. Okay, locked rotor current, Adam. The locked rotor current assigned is L. Unless you know otherwise, what's the locked rotor current of this pump? I don't know. So you take the default that comes from the system. It's a high locked rotor current. That's based on, but it's a 2 horsepower though. It's a small horsepower. Leave it. Power factor. Typically, smaller motor have screwed up power factor, guys. Bigger motor have higher. Leave it as a default, unless you know. And gentlemen, you leave everything as a default, and what do? Hit off. Finish, and here is your motor.
Is the gas boiler full circuit? What would that be under them? Is that just a receptacle plug-in?
Absolutely. Through a receptacle. Absolutely. Through a receptacle. So if it doesn't have a horsepower, guys, or if the horsepower is so small, if it has a horsepower, put it as a motor. If it doesn't have a horsepower, volt amp, put it as a receptacle. Okay. Can I have your attention, guys? Then, next, you guys are going to go, I'm not going to do it, but you, my friends, are going to go all the way and fill all this information. But okay. So Adam, we're going to go to same way, recirculating pump to gas boiler pump. We'll put it as a receptacle load. Unit cabinet heaters. We'll look let's do a unit cabinet heater, shall we? Unit cabinet heater 1, it's a quarter of a horsepower. So, well, how do you put it then? As a motor. As a motor, because if it has a horsepower, what do? You put it as a motor. So that's easy. You guys will do it then. Anything that has a horsepower, gentlemen, you're going to put it as a motor. Keep moving all the way. Exhaust fan, all of them have horsepower motor. I'm going to do one of them, the 120 though. I'm going to go exhaust fan number 1, Adam. Exhaust fan number 1, it says it's a quarter horsepower motor and it's 120. And it start across the line, okay? You guys are going to do all of them. I'm just going to do exhaust fan number 1. Okay, so let's go. It's a motor. It's called exhaust fan dash 1. It is a quarter, so 0.25. Was it quarter? Okay, now what was the voltage in it? 120. So let's go type a 120 voltage. It still say 3-phase here. Can you guys see that? Is it 3-phase though? It was single phase, so please flip to single phase. One more time. Make sure if it's single phase, you flip to single phase load because it was a single phase. right? So 120 single phase, and then capacitor start induction run. Yep, leave it as a default. To give you a different option, leave it as a default. exhaust um, exhaust fan -1 as a comment. Go next. Leave everything here, guys, as a default. Don't mess with it. And hit finish. And gentlemen, you got your exhaust fan. Did you guys hear me that you have to pay attention to the phase? Is it three phase or is it single phase? Right? Adam, does it make sense? Now, can you guys assure me we picked all the loads, right? The rest is just start plugging them under the right component. On the right component. Do we have a VF? No, we don't have UPS system, do we? And we don't have a load of a UPS system. So we're going to plug this stuff in. UPS will be plugged into receptacles. Okay. Now, can I have your attention, guys, for one more second here? Now you guys will fill all this information in the software. Now, we're going to go, remember, you're going to fill this information. There's one little trick, Adam. So say exhaust fan number 2 is the same as exhaust fan number 1. Can you guys see that? Right click on it, it says copy. Do you really want to copy this one? Yep, copy it. See how it expedite the process for you? Did it copy it? Copy. It should copy it. All right, I don't know. Copy, we have to paste, yeah. Copy and paste. Now here's another load that's exactly the same as exhaust fan number 1. So what do? Double click on it and just name it exhaust fan -2. Done. You see, guys, now exhaust fan -2 and hit. It's identical. And here at the bottom, don't forget that's going to be a 2. And here's an exhaust fan number 2. Do you see how you can copy and paste loads if they're the same thing?
Where did you go to paste?
Right click, you copy, and it click on the load, and right click on the load, and it says, do you want to paste it? And you paste. You can delete, edit. So made a mistake, right, Adam? You made a mistake. What do? Click on any one of them and say you can either edit or delete. So you made a mistake in the C unit. Double click on the C unit, it opens it. Do you guys hear me? You can double click on any one of them. You want to delete any one of them, you just click on it and hit delete. It will delete it. Very easy, very simple, huh? Next step, gentlemen. And you're going to fill this information. So please hold your horses, please, to the next step. Next, how are we going to start these? How are we going to start? Now we put them. You guys will finish the rest. Now, how are we going to start them? Here's what I'm going to tell you. Step number 1, guys, I want to start my lighting panel. So here's Adam. Look at this. Drag. Can you hold and drag the lighting panel all the way and put it on step number 1? And hit yes. What you have just told that, do you see how it assign lighting panel under step number 1? Meaning when you start your generator, first start the lighting panel. Did you guys hear me? That's it. Now I need more steps. Cool. So do you guys see this thing here? This icon here? Click add a step. So we'll add another step. Okay. I think you should be able to edit step. No, let's not go there. All right, so I have one step. Now, next, I want to go grab, Karen, I'm going to go grab my receptacle panel and put it on step number 2. Done. Okay. Now, grab another step. Step number 3, leave it alone. I'm going to go all the way to step number 4, guys. Step number 4. On step number 4, I'm going to go drag my air handling unit and put it on step number 4. Okay, now what am I going to do with step number 3, Derek? Do you see these little motors that you're going to be loading, guys? All put them under step number. We're going to put them on step number 3. So let's go grab exhaust fan 1 and group exhaust fan 1 and put it under step number 3. Yep. And exhaust number 2 under step number 3. Yep. And all the tiny motors that you guys will be loading, boiler pumps, exhaust fans, what else? Boiler pumps too. Same thing. Step number 3. Okay. So exhaust fans, boiler pumps, everything else is going to be on step number 3. That Adam we're going to be installing. Okay. What are we missing? We're missing a chiller. Where's the chiller? So let's go step number 5. I'm going to put my chiller, first chiller on this one. Okay, yes. So now my chiller is in step number 5. The last thing I want to start is my chiller. Did you guys hear what these steps are? Last thing, I don't care if they get hot in the, I'm going to start way at the end. Meaning, you know, you talk about minutes here. Okay, we're starting it at the last minute. I need one more step, guys, for future condensing unit. So could you please, guys, go to condensing unit and right click on it, copy load, go to the load, click on the load. I copied the condensing unit. So condensing unit, right click, copy, click on the load, right click, paste. Now I have a load exactly like condensing unit 1. Double click on it, guys, and name this as condensing unit dash 2. That's the future one. Now, do you guys remember what the kVA for that one? The amps for that, the amps for the future one was 44. So let's see, try 9 if we can get 44. We're looking at 44, Adam. So let's do 8. Okay, so that will be 9 wouldn't cut it. So 8.5, 44. Let's make it a 9 then. Okay. Now they might not make a 9. So what do? Actually, the cut sheet says 10 if you look at it. So let's go put it 10 actually. Put it 10. Because the cut sheet shows 10. It gives you 51.19. But if you want to manipulate it, you start manipulating to get the full load down. Okay, that's your exhaust fan number 2. Right here, guys, provided by manufacturer and say future. Future use. For future use, right? So that's for future. Everything else, Karen, stays the same. Go back here. Everything's pulse width modulation and what's not. So it's a 10 horsepower, 2.8 3-phase, and click finish. Am I going too fast? Click finish. Now you have a chiller, number 2. I want to start one more step. Click on step number 6, and I'm going to put my chiller number 2 on step number 6. So the whole idea, Adam, when you put loads on steps, the bigger loads, leave them until the end, especially not the most important. I mean, chiller, okay, people can live for 10, 20 minutes without chilled air, but light, you need them. Receptacle, they need to be up and running, right? So your light, typically emergency light, the first step, then receptacles, then data if you have data. Okay, next, what you guys going to be doing, any question, guys? So I assigned, so Adam and Brian, my friend, you guys will be inputting all this information, Matt, all this info directly into this software. Now, suppose we're done. We're not done, remember, we're not done yet. Suppose we're done. When you guys are done, let's go run size. You're done. So when you drop your fixtures, make sure you drag them. If you try to drag something that already exists under the same step, it will tell you, would you like to assign F and load to step number 3? Yes, it's already assigned to step number 3. So, so you put all this information. Now let's go run and size this generator, shall we? Any question, guys, about building your steps? That's it. We're going to have 6 steps for this project. And we're going to assign the loads as is. The rest of the load that you're going to bring, Adam, we're going to dump it under which step? Step number 3. Because they're tiny little babies. Baby load, 1.25 and what's not. Okay, let's go size your generator. Hit that little icon here. Size gen. Can you guys see that? Hit the sizing gen. Cook. And the size of generator so far. Here's your size of your generator. It's 175 kW. Can you guys see that? Now you get a report like this. The most important site rated standby is that number. 175 kW generator. It will give you all the information that you put, guys, about the maximum starting voltage and the kW and everything else, and the temperature and the starting capability. Look at that, the starting capability of this generator and the temperature. Gives you all this information. Down here, Adam, will give you information about that you put standby to it, 120 parallel, 3-phase diesel, 1 generator. Um, all the info, the default info that you guys put it right here. Can you guys see that? Now, of course, your generator is going to be different than that because you need to add more loads to it, right? We need to add more loads to that generator. Any comments, guys? Any questions? So that's this report. If you click on load running, it will give you guys information about your loads. Now, the first info, if you click here, it gives you information about your loads. So here's my total load running is 153.9. And all this KW, that's in KW. Running load, steps, power factor is 92. Maximum step is 65. And a bunch of other things. The last thing is generator set configuration. Adam, if you click on that one, it will give you the engine alternator model that you need to use. So it's giving you an alternator UC3H. You might have to check with Cummins when you size it actually. And all this other information that you need that probably betray to the engine. The most important thing is the engine and the alternator. The engine alternator. It tells you, because what is a generator? Do you guys know what a generator is? A generator is 3 pieces. An engine like your car engine, diesel engine, it drives an alternator, right? And have a big radiator to cool the engine. That's what a generator is. There are 3 pieces of a generator. So, and that will give you the, so you have your engine, you have your engine, you have alternator, and the exhaust. Not the exhaust, the radiator. Sorry, radiator. You need to have a radiator. Radiator here. So the radiator, Adam, like your radiator of your car, will cool the engine while it's driving the alternator to generate power. That's so you say here's the sizes of these, and so then you take your power from here and put it on your building. Any comments? Any questions, gentlemen? Any comments? Any questions? Is that hard? This should be done today, in a heartbeat, right? Piece of cake. Now, when you're done. Not now. When you're done, you're going to print 2 reports for your friend Chad out of this software to prove that you have done it. You guys have to save first of all, you have to save this project into the network under generator sizing. There's a folder that says generator sizing. So please, if you don't save it there, it's not done. Save all the stuff that you do, all the lighting calculation, all the stuff you have to be saved in the network. Okay, then you have to print the following reports. If you hit reports, Adam, print reports, print review, you can print step-by-step load or recommended generator. So let's go click on a recommended generator. Here's my recommended generator. That's a report that you guys are going to show all the stuff that you have to put into there. So that's my recommended generator. 175 kW. Can you guys see right now? It's a recommended generator report and all the information about my generator. How much is going to be the starting and the running and what's not. Running load and power factor, model of engine and alternator. All the stuff that I was showing you before, it will put it in this report. So hit print, done. Okay, that's report number 1. Click on it. We don't want to print it. Then go click, guys, on report. That's the engine. Go to the step-by-step. You guys see the junk that you were inputting right here? I told you. This is where you put the engineering firm at the top and fill it information. So I need info there. You fill information. This is step by step. It will tell you project parameters, the fuel that we're using, and how many phases, frequency, parallel, yes, standby. All this information is taken into consideration. The most important thing about this step, gentlemen, is really the steps. Can you guys see step 1? Has lighting, LP. Step 2 has RP. Step 3 has all the information, Adam, that you inputted in the software will be printed from here. Okay, so here's a step, all the steps that you did 4, 5, all the way as well. So step number 6, for example, has my condensing unit 3 running KW running KW as well as starting KW, and a bunch of other things, power factor and what's not. Any comments, gentlemen? Any questions? Would that be easy, guys, to run it? Matt? Yes? Karen? Would you be able to finish it today? Yes? No? How about Adam? Would it be done? Brian? Okay, so why don't you guys go ahead and, as long as it doesn't take you much to plug in all this information, and then when you're done with this one, let's click into the low voltage stuff. Low voltage stuff. Oh, before you leave, do me a favor. Go File, Save. Oops. You can close out of this. How do you get back? How do you get back to your, yeah. Click on this. You click back, you click on that icon here. It takes you back, guys, to the project. Click back. How do you go back to where the sizing? Click here, takes you back to the sizing. If you want to go back, actually also this icon says close this window. So you can click here, go right here. Okay, now if you click on that icon or double click on this, it will take you back to the project. Okay, Adam, please go File, Save, Save As, and go to the instructor folder, to your team folder online, and please save it online for your friend chat. So save, I want to go to the network, to my team folder, under commercial project. If it's not here, guys, it's not done. Generator sizing, can you guys see where I went? And just call it commercial project. I always like to put dates on things. So put 11, what's the date today? 11/19, 13. And so commercial project 11/19/13 and save. Commercial project has been saved. Okay? Did you guys hear me? Everybody knows where we're going to be saving it? Okay, so now all what you need to do, guys, you're done up to, I would say, 80%. Matt, what you need to do is go put all the other loads, put them in the software, rerun your calculation, and save the system. Don't print anything, Adam. Do not print anything yet. Don't print anything. We print the reports at the end and you put it in your binder. And you guys will get 10 points for doing this report. Is that a piece of cake? Okay, thank you. That's all I have.